and supporting the Core Valley Line Transformation Programme. Simon's railway career has spanned 22 years in overhead line electrification and has been in many different aspects of electrification design, from system principle through to construction, and there's extensive knowledge of testing and commissioning of overhead line. Having started in 2000, his career has taken him to Cardiff Valley Lines via Swindon, Brisbane, Auckland and Maidenhead, but we shall refrain from asking which location he prefers. With projects including Auckland Electrification and Crossrail on network function and Network Rail's the Greater West scheme, he's got extensive knowledge across multiple areas. His partner in crime today in presentation is Nick Rowe, who's employed by Amy as the Regulatory and Customer Manager, specifically working on the Core Valley Lines Transformation Programme. With 37 years in industry, Nick has worked within all sectors for companies such as British Rail, Amy, Network Rail, Crossrail and London Underground, both client side and as the contractor. His vast experience ranges from asset management, rail operations, sponsorship through to programme management, project controls, logistics to include possession and resource planning, and everything in between. I know I speak on behalf of the Core Valley Lines delivery team to express our gratitude for having these two high calibre gentlemen working on our flagship scheme in Wales, so thank you very much for that. That's it from me for now, folks. I'm going to mute myself and I shall hand you over to both Nick and Simon. Thank you.
Cool. Thanks very much, Carl. Can you hear me okay?
Perfect.
Fine, okie. What I'm going to do now is just pull up the presentation. So we've got one presentation to go through, which Simon and I will take you through. So just bear with me 1 second. Okay, so welcome everybody. As Carl said, Simon and I will take you through the Core Valley Lines network, what that Core Valley Lines network actually is, how Amy Infrastructure Wales plays a part in that, how we're related to Transport for Wales and indeed the train operators, and what it is we're going to do to transform the network. And that will sort of take us over the next 30 minutes or so. And as Carl said, we're more than happy to take questions at the end. Okay, so just as by way of introducing what it is we are here to do, the Core Valley Lines network itself is depicted on the right hand side of the slide. It's actually all of black lines. So this kind of orangey line here is the South Wales main line. So this is Cardiff Central here. And this is all Network Rail owned infrastructure, owned and operated. And on March the 28th, 2020, everything in black you can see north of the Network Rail network was devolved by Network Rail to the Welsh ministers, and through Transport for Wales to Amy Infrastructure Wales to become the infrastructure manager of this whole network. And as you can imagine, it's a railway, so it's everything from the boundary fence, cuttings, tunnels, vegetation, signalling, track, telecoms networks, the whole thing we are responsible for as infrastructure manager of that network. We're also responsible for all the stations and property, and similarly to the Network Rail model, we lease out all 55 stations to the train operator, which in this case is Transport for Wales Rail Limited. That's the operator of passenger services on this network. The boundaries exist. So if you're familiar with Cardiff, to the east of Cardiff Central, just at the bottom of the ramp where the line to Cardiff Queen Street goes up and over the South Wales main line intersection bridge, we take from the bottom of that ramp. So everything north of that ramp is CVL infrastructure. And the boundary to the west of Cardiff is between Ninian Park and One Grand Park. So again, everything to the north is a CVL network, managed by Amy. So in terms of the company that Simon and I work for, Amy Infrastructure Wales, we are defined under the law as the infrastructure manager of that network, the CVL network. And primarily that sort of covers 4 areas, I think. So asset management. We have a slightly different relationship here as opposed to what people are perhaps more familiar with at Network Rail, because unlike the Network Rail model, We don't own the network, so we're just the operator of the network, whereas of course the Welsh ministers and through Transport for Wales are the owners of the network. So that drives a different approach to funding, for example. So some of the funding decisions are out with our responsibility, and we would go to the TfW, the client organisation, to have discussions around investment. Operation of the network. There's a staged change to how the network is being operated. When we transitioned the network back in March 2020, the whole network was signalled from 3 different locations. So we've got a signal box at Rada, a signal box at Abercynon, and the Rumney Valley, this line here to Rumney, is signalled from the Rail Operations Centre at Cardiff by Network Rail. So that's how we transitioned the network to us. Since that time, back last December, the signallers have transferred that work at Rada and Abercynon signal boxes. So those signallers are now Amey Infrastructure Wales employees. Next January, we are commissioning a new control centre at Tafts Well, and that will gradually start to take control of the network. So from January, that control centre at Tafts Well will take over the signalling of the Treherbert, Merthyr and Aberdare lines, which means that the current signal boxes at Abercynon and Rada will close. So the control and command will transfer to the control centre next January. And then during 2024, the control of the Rumney Valley will transfer from Cardiff Rock to also the Tafts Well control centre. So, by the end of December, by the end of 2024, we will have taken full control of the operation of that network. The third big thing for us is, in addition to our IM responsibilities, we manage the transformation project, and we'll tell you a little bit in a moment about what that transformation project actually is. It's a huge spend by the Welsh Government and other investors to deliver a transformed network capable of what we're calling the South Wales Metro. And I've got a few slides on that in just a second. And then the final bit is compliance. Obviously, I put that in there specifically because, the regulatory compliance is one of the things that I'm responsible for at AIW. So that's particularly why I'm involved in this contract here. Okay, so that's the geography, if you like, and what the CVL network is, and who Amey Infrastructure Wales Limited is as infrastructure manager of that network. This is the contractual structure. I mean, I don't want this to become overly contractual, of course, but the reason we're putting this slide on here is just to explain the differences in the companies that are at play here, which is different to the Network Rail model. So as you can see, Transport for Wales are the authority, top of the tree. Amey Infrastructure Wales is contracted by Transport for Wales to be the infrastructure manager of the CVL network. But as infrastructure manager, we in turn have contracts, track access contracts with the train operators that allows them to access the network. So we actually have contracts with charter operators, with freight operators and other passenger operators, but we also have a contract with Transport for Wales Rail Limited. And where this does get a little bit confusing, and sort of hence me feeling the need to put this slide up, is that there is a difference, of course, between Transport for Wales, the authority, and Transport for Wales Rail Limited, the train operator. So we have a relationship with both of those parties because, of course, we're employed by TfW to be the IM, but being the IM, we have to have a track access contract with Transport for Wales Rail Limited to operate those services. And, there's a lot of chat around how we could optimize that relationship and bring efficiencies to that. The only kind of issue in this kind of situation is that under the law, I'm required to act impartially between train operators. We've got to treat operators in the same way. So I can't, despite the fact that TfW Rail are my client, we can't be doing special deals for TfW Rail, for example. We have to treat all operators in the same way, and the law requires that I do that. So I'm keen to. We've mentioned the South Wales Metro, so this is the aspiration. So this is what the Welsh Government are invested in. So it's essentially a turn up and go style service. You won't necessarily need to know the timetable. You will always know that there'll be a 10 past the hour, 20 past the hour, half past the hour kind of service. So it's a turn up and go style service. It'll run all day, every day. So high frequency, and it covers the network shown in the map there. So the CVL is the bit in the sort of the yellowy colour. The wider network is shown outside of that, so that's obviously on network rails network. So when we talk about South Wales Metro, it's the train service from the core Valley Lines network down to Penarth, Barry, and round the Vale of Glamorgan line to Bridgend onto Maesteg. So that's the service that's being delivered, and because the train service is being enhanced outside of the CVL network, we are actually funding improvements to Network Rail's network at certain places to allow that enhanced train service to operate. So with that high intensity train service in mind, that is what drove the scope of the transformation project. So this is what we're spending our money on, to transform the network to deliver that level of service. So I've just got a few slides here, a few facts and figures. So in terms of signalling, you can see these are the changes that we're making to the network to enhance it. Signalling is obviously a key enabler of capacity enhancement. So we're essentially increasing the number of tracks and increasing the number of signals, which means that we can reduce headway to allow more trains to run on the same tracks. In the doing, we're upgrading, to axle counters, for example. We're upgrading the SCADA network. We're doing lots of upgrades to the cable route and location cases, all culminating in the new control centre, which is being built at Tafts Well. So that's where the network will be controlled and operated from in the future, as I mentioned a moment ago. In terms of the track, yeah, it's essentially double tracking and line speed improvements. So we benefit because a lot of the network was double tracked, previously before the 1960s. So the embankment or the formation, is still available to put the second track back in. So that is a good thing. Of course, as you all know, the track has been slewed in the meantime, so there is still a lot of shuffling of assets around. The cable route needs to be moved, obviously, to allow that second track to go back down. And we are investing in line speed improvements. So this is all about, again, a means to increase capacity, because the faster trains are running, the quicker they can get from A to B. So we are doing lots of line speed improvements with some quite challenging geometry to achieve the target speed. There's various track lowerings happening, and this is about electrification, which Simon will cover in just a second. We're also providing level boarding, so there are adjustments between the track level and the Copa level at stations to allow level boarding for the new fleets. Talking about civil engineering, we are preserving the route availability that exists currently. So where we are increasing line speeds or double tracking or putting deeper ballast on structures, we are also working on the structures to ensure that the route maintains the same RA that it does have today. So there's no reduction in capability of the network. We've got new platform extensions. We're doing various modifications at stations. As you can see, we're opening a couple of new stations. Electrical power. Now, we are electrifying the CVL network, which Simon will cover in a second. So, of course, we are introducing high voltage supplies to the CVL network at 2 locations, and then, of course, the distribution network that then flows on from that. As part of the new fleet introduction, so there'll be 2 new fleets being introduced to the CVL network to deliver the South Wales Metro. One of those fleets will be based at a new depot at Tafts Well. So what I'm going to show you here is a fly-through video of the new depot at Tafts Well. So if you can imagine, this is the driver's perspective on a train at Tafts Well station facing south, facing towards Cardiff. So I'll just start you off on the journey. So departing southbound, routed into the depot, you can see the scissors crossover here. That S&C is in, it's on the ground, not yet commissioned, obviously. You then take the left-hand route into the depot. These crossovers are in on the ground, but not yet commissioned. There's a very tight 25-metre radius curve into the depot because the site is sandwiched between the A road and the existing railway. Here you can see we're coming into the sort of the fan of sidings that spread out towards the maintenance shed. That's off to the left there. That block you can see coming into view in the middle of the screen is the wash plant. So So that's where the trains will be cleaned. We're now running sort of around the eastern periphery of the depot. And as we come around the corner, if you look to the left, you'll see the bogie drop facility. Underframe cleaning exists in that area just to the left there. Now, right in front of us, you can see the new control center. So this is the CVL ICC. It's on the same site, but it is segregated from the depot by a security fence. As we loop around this bit now, we're coming into the holding sidings. So you can see the overhead portal structures here in the stabling sidings. Those will have the conductor bar so that the trains will run in on battery power, but as soon as the train is stabled by the driver, the pan goes up and then the batteries can be recharged during the time that they're stabling there. So those are the stabling sidings. You can see the security cabin right in front of us now. That is the entrance to the depot, and it's a combined security for the whole site. And we're just flying over the car park, and then the camera will loop back to look at the whole site. So that is Tavswell Depot. Okay, back to the presentation. Oops, sorry, bear with me.
I'm just counting all the applauses, Nick, while you're getting to the slide.
Sorry, not quite sure. Okay, so that's the depot fly through. So that's Tavswell, the new depot. We are also upgrading depot facilities at Canton, Treherbert, and Rumney to take into account not just the sheer quantity of new trains coming, but the different maintenance requirements that those new trains have. Okay, and then last but not least, the electrification of the network. We're calling it smart electrification, which Simon will discuss in a second. We're electrifying around 170 kilometers of track, which means like around 3,000 masts. So, a significant electrification program. And we've got a couple of technologies which are unique to this network. Well, not totally unique, but as Simon will explain, they are certainly a variation on a theme that's gone previously. So those are the PESs, the permanent earth sections, and the catenary free sections. Okay, so that's me done in terms of the introduction, in terms of what the CVL network is and who we are and how we manage it. I'm going to hand over to my colleague Simon now, who's going to take us through the actual electrification of the network.
Great. Thanks very much, Nick. Hopefully you can hear me. Take that as a yes. Right. Okay. So I'm here to talk to you about the smart electrification that we're installing. So if you'd move on to the next slide, then please, Nick. So our smart electrification is in line with NetRail's environmental and social minimum requirements projects. So the hierarchy of trying not to do anything, and then if you're going to do anything, try and reduce what you're doing, and then what you are doing, building it clever, and then making sure it's as efficiently as possible. So we've identified that we need to do something with electrification. It's generally it's obviously a low carbon solution, having electric trains rather than diesel trains running around. So we're not able to do item one. So going on to building less, we are building less. It's not a full electrification scheme like others such as Great Western also, because we're using a metro style efficiency, so you can have hybrid trains as the speeds are running slightly lower. And we've also got some earth section, and then moving on, we've got some earth sections. So that's building clever. So although we have got some track lowers, we have got a very minimal number of bridge lifts and reduced number of track lowers that you'd need for an electrification project. Certainly on this network, it was when it was originally built as a to service the valleys, it was fairly small gauge. And then and I'm sure someone will ask me a question about the clever composite mast at some point, but I think that's come in too late for us as an inclusion. And then building efficiency is trying to be use the technologies in construction to do that. So next slide then, please, Nick. Okay, so as Nick's previously said, we've got the two depots. He's given you the fly through of Canton. Taftswell, sorry. The rest of the network we've split up into 9 route sections. This is due to different design houses designing different sections of it. Then you've got this totals 170 single track kilometres, and we're using the UKMS 100 design range. Obviously that's got a pantograph spacing of 81 metres. Our pantograph spacing on our metro trains is slightly less. It's about 40 metres. So we've done some modelling so far to reduce that, and we'll need to be updating the UKMS IC certificate for it. We have yet to do the testing on that, but that's in process. We have also got to add in a PES insulator as well, because obviously it's almost a half neutral section. We've got 30 catenary free sections, which is where we don't have any wire over the track at all, and the train is then running on its internal battery storage, or on the tri modes they've also got a diesel generator, and that's down for taking the trains down to Barry Island and Penarth. And then, as I say, we've got the 60 permanently earthed sections, or PESs. So in total that's 24 kilometres of PESs, and 81 kilometres of track we're not electrifying. Okay, next page, isn't it? Okay, so how are we doing it? So because we've got a captive system, we're able to work with our rolling stock here to produce a single solution which is best for all. So it's not an all electric train, it's a battery train, or has a battery, so can get between the two. We are using surge arresters as initially used, I think, on CIB and also in Scotland, to try and reduce the clearances and control the clearances. As I say, we've got beacon control. We're not using auto APC magnets, and we are using beacons to try and control the train, so the trains know where they are. And then in the depots, as Nick touched on at Taftswell, we've got static charging, and I think the idea there is using conductor beam to help reduce the length of the wired section. Some of that was also due to signal sighting and the tight radiuses that you've got going into Taftswell, so that the train can stop, it can raise its pantograph, and it can charge there. Okay. Benefits. So we've got, although we've got the most complex station we are now wiring on the network has got 3 platforms. We are not yet electrifying Cardiff Queen Street or extending the electrification at Cardiff Central, which are more complex stations, or even Pontypridd. We're avoiding doing any interventions on any of the listed viaducts or in any of the tunnels. And Cardiff University at Catenary has got a very sensitive setup room there, which is very susceptible to EMI interference. So actually around Catenary we have stopped the electrification to improve the EMI and the noise that we're producing, so that their systems and infrastructure and their testing devices in the university are unaffected by the work that we're doing. So we've got some challenges that we have created for ourselves in doing the smart electrification that you don't normally have to worry about on a standard scheme. Because the amount of cabling that we're putting in, we've then got essentially we're creating a giant capacitor. So we're having to look at shunt reactors and things like that at the end of some of the lines to try and reduce the build up of that charge. And then a completely new problem for OLE designers is the percentage charge in the batteries of the trains that are running around the network, and also what the temperature of the batteries are, which is something as an OLE designer you normally are quite happy not to worry about at all, because it's not been a problem. Okay, so next slide then, please. Okay, so this is roughly how the system works. This is how a train transitions from a wired to an unwired section. So you've got your train coming along on the left-hand side, and then it goes over a catenary free on section beacon that tells the train to lower the pantograph. This is at least 13 seconds. It's 102% of the line speed away from the obstruction. In terms of that as well, we are ensuring that as a backup that we're taking the wire out above the train so that it's if the train doesn't read the beacon, the pantograph extends so much that the auto drop device kicks in, and then it also lowers that way. So it's a backup for that, and then it should be able to go underneath the obstruction nice and clear. I think actually the 6300 might have slightly tweaked just a bit higher than when we did the original presentation, but it's sort of, I think the NTSN requires 6.2 for interoperability as well, so we're taking it out above that. Okay, next slide, please, Nick. Oh, okay, sorry, I was expecting it to come, I've missed a slide, sorry. And then to come, when it comes back into a wide section, it then essentially goes over catenary fuse off section beacon, and the train tells the train to raise the pantograph. Obviously, if it doesn't read that, the train will get to the next station and the driver will realise the pan's not up and have to raise. So then moving on to permanently earthed sections. So this isn't anything new. So for example, on the Upminster branch in Anglia, there's a PES section under a couple of bridges there, and that's been around, I think, since 1980s or early 90s. I'm sure someone will be happily correct me on that one. And then recently on the Paisley Canal up in Scotland. With those, what's happened, the trains are just coasting through, so they're just normal electric trains, and so they've looked at signal spacing and likelihood of where the train is going to be stopping. They are the PES insulators in that respect is essentially a half neutral section BICC that's just been stretched for the trains to run across and into the earth section, and that's not yet in, or no longer in Network Rail's asset policy. So we've had to do something slightly different. So Nick, if you can go next one. So how do our PES insulators work? So here we've got a few slides to run through that with you. So here again, you've got the little train. I apologise for the animation, and that's coming along. Currently the pan is up. It's running on the 25 kV live infrastructure. The VCB is closed, and the way its attractive effort is from the overhead line. So for next slide, the train's going to go over the PES beacon. So the train has picked up that it's gone over a beacon. The pantograph is still raised, although the wire is still seeing it's above it is still live. The traction power is transitioning from OLE to the batteries, the onboard energy storage, and the vehicle circuit breaker is closed. So then it's just about go over the PES insulator on the next slide. There we go. So it's now in the permanently earthed section. So the wire above it now is earthed. The pantograph is remained up. The vehicle circuit breaker has remained open, and its full tractive effort is from onboard energy storage. Okay, and then it's then going to transition across out of the PES. So here there's some intelligence on the train. So the pantograph is now picking up that it's now back under live equipment, and once it realises it's under live OLE for 2 seconds, the vehicle circuit breaker will again close, and it will then transition and run back on the 25 kV OLE, therefore recharging the batteries that are in the train and powering it on for its onward journey. Yeah, there you go. So we've developed the permanently earthed insulator, PES insulator. So this is slightly different from a section insulator. It's more akin to the neutral half a neutral section insulator. We have worked with Arthur Fleury to develop this, and there's been I think a total of 5 components that are different on this than their previous neutral section. So in this we are going through an acceptance panel through AMI Infrastructure Wales, because obviously it's not a Network Rail project. So, but it's the process is very much similar. We have undertaken dynamic modelling on this and uplift, and reviewed that against our trains our train pantograph spacing, and found that and proved that it's all currently compliant with the NTSN energy requirements. Okay. So one thing that you've have a problem with as an electrification engineer on a smart infrastructure scheme is that you've got to worry about the battery modelling. So ensuring that the train has still got sufficient power in the batteries to power its way around. And from the slides Nick was saying, there's a large unelectrified area from between Cateys and Gibraltar round past Cardiff Queen Street and Cardiff Central, and then before you're coming back up to Rada, where you get more power again. So it's looking at making sure that the battery there, after in a degraded life, has got sufficient capacity in it to still power the train through. Also, we've got to worry about the battery temperature, which is also something that is a problem, because obviously the temperature of the battery, if it gets too hot, the battery then will start self-managing itself, or the train will start self-managing the battery. So there's limitations on how much you can accelerate at full capacity while the train is fully loaded up the incline, and that's about 30 seconds on full acceleration. So that's something else that, as an OLE engineer on this project, that you're having to look at, which is something that you would quite happily not normally have to get involved with. Okay. So where can we approach this for future schemes? And so where you've got a captive fleet, it's something that you can integrate with. You can reduce infrastructure and only electrify where is required. So, for example, Belfast, Northern Ireland, if you wanted to start looking at electrification there, that would be something that you could think about this, because it's a very captive area. Or tram networks, I think East West Rail might be looking at, for some of their schemes, if they should be looking at full electrification, or if Ireland is the way forward for them, depending on the capacity that they are looking at. Anyway, it is a way that we can get towards zero carbon by looking at building less and using the battery technology that is becoming more prevalent in the road network, obviously with the advent of more and more electric cars. Okay, okay, next slide. I think that's it, Lee. So yes, so now moving on to questions. I saw some come through while we were on that.
Yeah, fantastic. I'll pick up from here if you want, Simon, and Nick, give you a chance just to grab some water. Thank you very much for that. Real good sort of, I was going to say a high-level deep dive, if such a thing exists, but in terms of the OLE structure, there's a lot going on, and suffice to say, we've now got some technical questions, which I'm going to firmly hand over to you, gentlemen. Thankfully, we've got one of our colleagues on the phone, Sam Jones, who's been answering a couple of the questions, but I'm going to start from the top, just to make sure we've picked everything up. So we've got one here. With regards to level boarding, will platform heights be uniform across the whole network?
There is a level boarding strategy, and I believe that is essentially generally the case. I think there's a within tolerance, and I appreciate. Sorry, I'm not a PWI engineer, but it is level.
Yeah, I
can.
No, you're right. So I can jump in here a little bit. So it is two standards. We did have to take some guidance in terms of, I think the standard had plus or minus 50 mil. Actually, but I think we're looking to get it a bit closer to plus or minus 25, I think, from memory. But I'm sure it's one of those things I can go away and check on and come back to you. But a good question all the same. Will the presentation be shared? Yes, it can be. So if we can get it PDF, please, gentlemen, we can get that sent out via the PWI Secretariat. Question from Stephen. From a smart digital depot perspective, how are you planning to manage and measure innovations that come forward which claim to deliver sustainability advantages?
Oh,
well, while you're thinking of the more technical answer, I know from our perspective as a CRIVE alliance, and we've talked about the CRIVE previously, it's a consortium of all of the delivery partners in TFW. We do have a sustainability measure across the whole program, in which every aspect, whether it be for the depot, across our stations, anything we're building, all that is being captured, and of course we get measured on it by Welsh Government, so I know it's captured there. And over to you, gents, if you've got anything else to add on that. No, okay. Well, there's plenty more questions to get stuck into. So next one from Miguel. My understanding is that only one pantograph is up. If the two pantographs are up and connected, they can bypass the SI and trip the system. I think that may have been answered in part by, yes, it has, by Sam. So yeah, the MV or the flirt train fleets are not connected together. Each pantograph powers the relevant unit of each train, and there are beacon readers on each unit. Of course, the fail-safe, as you mentioned.
Yeah, there is a slight difference, obviously, Miguel, between a sectional insulator, which is designed to ensure the train doesn't lose power as it passes over it, such as over a crossover, and the PES insulator as well, where you're deliberately trying to break it. But yeah, as has been answered already, the trains are not connected electrically in terms of traction power.
Thank you. We've got a question from a different Stephen here. How do you manage wire wear where you have a non-wired bridge at the interface?
I presume Stephen is thinking about where the pan is coming up and hitting the wire there. Obviously, as it comes back into a wired section. This is under normal maintenance procedures, and we've been looking at the forces at which the pan raises and strikes the wire. Ironically, where you've got the Class 800s doing that on Network Rail's infrastructure, I think on East Coast, Great Western, it's a similar kind of problem they've got, and it's nothing that has been seen to be any worse than anywhere else, because there is a lot of variables that come in. It doesn't strike necessarily at exactly the same point each time, because of the train speed, sort of even a mile an hour or so difference is positioning that quite a bit further down the track. But then there's normal maintenance procedures where they will be going through and making sure what the wear is on the overhead line.
Thank you, Simon. Question from Brian. Good afternoon. So thumbs up from Stephen there. From a sustainability point of view, what provides the power for the static charging at Taftswell? So Samuel's jumped in here and provided that. So the power is fed to static charging from the rest of the CVR network, and cable feeds are provided from Taftswell MPTSS. So I guess that's the technical answer. From a sustainability about where we get our electricity from, 100% of it is from renewable sources, of which 50% is within Welsh sourced renewable energy. One of the things which is unfortunately a bit behind the times to be able to integrate into this program, Brian, was other renewable energies. So we were working with riding sunbeams. We still are for the future, about to see whether we can possibly change some of our TPSs to try and have a different type of power source, and those conversions obviously to get it from DC across to AC and all that good stuff. But that's in play at the moment. We just haven't been able to implement it at this point in time. Okay, scrolling down. I think we've got some real advocates here. They're answering the questions for us, which is fantastic. Okay, there's one here. What is the specification for how long trains will be required to operate on battery power?
That generally depends on the battery modelling and the two different types of rolling stock we've got. As say, one has actually a tri-mode, which has then got a diesel generator on it to come for the long sections down to Barry Island and things from Cardiff Queen Street, whereas I'm going to get the types the wrong way around here, and I'll say the flirt and I'll mean the NV. And the MV has got a smaller battery and is only bi mode as well, so it's a lot more restricted on the length of catenary free sections and where that can travel.
Good answer. Couldn't have said it better myself. So next question, if you can put your N -1, -2 hat on. You said there were two times grid traction power sites, what happens in N-2 with discontinuous electrification, i.e. are you running very, very long lengths of insulated HV cables to bridge the gap?
Matt, the answer is yes. This is then creating the capacitance issue that you don't normally see on electric railway. Obviously, previously you've sort of got feeders straight from the feeder stations to the overhead line, or where it's an AT system through a small bridge, or sort of maybe a station and stuff a kilometre long. Whereas here we've got some considerably longer sections. I think we've only got N-1 rather than N-2 robustness. Carl, is that correct?
No, I believe we've got both.
Okay, all right, sorry. Yeah.
Another technical question here, and I'm going to have to read it verbatim because I absolutely cannot answer this one. Would the aforementioned beacon system be using the existing ETCS standards, such as Euro Belize's, or would it be its own priority system? Of course, it's a more non-electrification question, and I'm happy to defer the question to another time.
I'd be happy to defer the question to another time because it's a non-electrification question, sorry.
As would I.
Yes.
We shall have to come back to you on that one. Okay, working our way down. They're coming thick and fast, but we're crunching our way through them. Are there any specific OLE isolation strategy challenges when dealing with this smart system and with PES interface, etc.? Are CMEs being proposed?
Yes, each electrical section is going to have a circuit main earth. I think as current standards. In terms of the isolation strategy, we have got some what we're calling bare feeder sections. So, for example, running a high level bare feeder adjacent to the railway through some of the starts of the PESs. However, we are not letting we are making people treat the PES as live at all times. And it's then the same electrical section. So if you're working in a PES, it's the same, you're treating that as live and getting the isolation either side.
Thank you, Simon. I see Nick's getting off quite easy here. There's a question here around, which I'll pick up, around cable theft. It is a real challenge for us. Suffice to say, we're rolling out a lot of hundreds of kilometres of cable across the whole network. Some of that is, of course, fibre. We are working really close with BTP colleagues, but of course, if you're hell bent on stealing cable, then unfortunately you will do. So we are trying to put as many measures in place as possible to try and help get into the community and try to explain the benefits of electrification, and of course the challenges and the risks to going onto the network, not only just trespassing, but actually to try and steal the equipment as well. And we are having certain successes in some areas, and of course we'll have challenges in others. Another question here around PES. Second question, when putting in the PES and neutral sections at challenging bridges and structures, is there any provision for increased freight gauge needs?
The reason for stuttering is the word increased. The PES section, as it doesn't require the electrical clearance. So that's where we are saving on the structure, on the soffit height of the structure. That's both above the wire and below the wire. So the actual PES insulator is potentially quite a few spans away from the bridge. We are making sure we've got 80mm mechanical clearance as per 27715, I think. And we've certainly got W68, and I believe it's W10 as well through there. So I think W12 is greater. Sorry, I'm not a gauging engineer. But I don't think that's one of the requirements we've got.
Okay, thank you very much for answering those questions. I'll just do the last shout out. Sorry, Stephen's come back. Yes, W12.
Mm-hmm. Okay. Yeah. No, I think W12 is the bigger one, isn't it? So.
I'm just going to do the finest. Sorry, the last final call for questions. Where everyone just come back through from Miguel. Sorry, but I didn't quite understand. How do you prevent a massive fall down of the system during a hookover?
Well, designing not to have hookovers, Miguel, is the first part. I don't know if you're meaning when the pan raises again afterwards, but making sure that's on a plane that it's not going. The pan isn't raising over any S&C or any complex bit of track. And through the PESs, we have been looking at making sure we review what the tension is. So if there's a hook over in the PES, obviously if the wire drops there, it won't be able to trip the circuit breakers, which will give you an idea of what's going on. But then putting some detection on TensorX there for it to see what the tension is to wire, and then obviously if that leaves and goes, you've got an idea that there's the wire down there.
Okay, and we've got one question just slipped through. We'll do this one, and then we'll draw the session to a close. It's from Matt. What MVA are you? Have you got incoming to the substations? I assume it's a classic, not ATF.
Yes, it is classic, and I have no idea. If you'd like to email me later, Matt, I shall dig that out of the MFD.
Fantastic. And lastly, I've got to let this one slip because it's from Brian. How long is the AMI contract to manage and maintain? At this time of the franchise change, as a result of COVID, when Keolis and AMI split, it went from 15 years down to 7. So I think we've got circa five and a bit years left to run on that, Brian.
March 28.
Thank you, sir. I'm not a million miles off. Great. Thank you very much. In that case, I must say, I think we peaked at 74 PWI colleagues on the call listening into what I personally felt was a really interesting presentation, and I hope it's been of real benefit to everyone on the call. So lastly, I'd just like to call at this point a vote of thanks for the 2 gentlemen who joined us today to take us through this electrification of the Cardiff valleys. Can I ask for a vote of thanks, please? Superb, thank you. Lots of hands up. And lastly, Brian, we said visited Taftswell last week with Carl, and my visits and this presentation has really brought your programme to life. Legacy projects, and you should all be very proud of what you leave behind when it's in full operation. Thank you for your time today. Fantastic. Thank you, Brian. It's really nice to have that feedback, and I can see. Is our hands of vote of confidence? I think it's a vote of thanks. I think it is. Thank you very much, everyone. Jock and Val, thank you, and we'll close the session here. Thank you very much. Take care.
Thanks, everybody.